I'm a helicopter pilot, and it's a great hobby, but I think if I had a crack habit, I would have spent less money. Today I'm going to talk to you about some definitions, the problem that we had at Adform with our user-facing applications, the solution that we came up with, and at the end of it, I'm going to give you some Uncle Pete's advice. First of all, we'll talk about anarchy. Anarchy is not necessarily a bad thing. It's just existing without some kind of hierarchy. Most startups commence with a level of anarchy because you know each other. There's 2 or 3 of you and you're working together and you know what you're going to get done. So what's sustainability? Well, we can use all of the ecological terms about what sustainability really means, but from a business perspective, it's viable indefinitely. So you have a business model and a product that people want forever or evolves over time so they continue to want it. Usability. Usability is something that people want to use. They find it easy to use. Most of you have in your pocket a supercomputer, either Android or iOS, and nobody taught you how to use it. You kind of guessed what to do. That's a good example of usability. So the problem we had in Adform was that we have 88 applications. They're all written differently. They were all written in a hurry. They were all written to solve real problems, but they're all different. And I mean different as different can be. You have multiple sign-ons. You have every JavaScript language and framework ever invented. No common UI components, no common features, little shared code, very little shared services, and 400 plus REST API endpoints, all with unique dialects. So when I say unique, what I mean is they're all strange and different. You kind of can guess what you have to do with them, but they're all special. All right. So what we have is a big bag of stuff, a big bag of functionality, loads and loads of features. And in the graphic, you see I've got Band-Aids on top of Band-Aids on top of Band-Aids. So these are features on top of features on top of features. And the user experience is strange. Okay, very strange. But it makes money and you can use it. You just have to be an expert user. So the value we have today is there. Here are the problems. We have sort of 4 areas I've got on the screen there that our publishers use, our campaigns use, our creatives use, and our data management platform use. Publishers is built in Lego. Campaigns is a bespoke plastic kit that you buy off the internet. Creative is made out of cardboard. And data management is made out of Playmobil. They all work. They are all great. They're useful. But you notice you can't actually put them together. You can't use any of the common parts. And so our navigation map, our link analysis map, is something like this. And this is only a small version of it. So if you're a user, if you employ Adform to do your digital marketing, you have this kind of problem to start up and learn how to do it. So we thought we'd need to fix that. So we get to a crossroad. So are we going to stay with anarchy? Anarchy is not bad, but it's anarchistic. It's going to take some work. Or are we going to go to usability and sustainability? So we met that crossroad about a year ago. So we decided on usability and sustainability, and we had a couple of real major goals. The first one was a consistent user experience. So regardless of what part of the solution we provide the user interacted with, it would be familiar. It would be the same. So in technical terms, it would be the same React components being used. We wouldn't have 22 different list components. We have 22 different list components. Why would you need them? We wanted to be able to have this modular approach to building applications so that they could be reused or reconfigured in the future another way. using perhaps other UI technologies, like going from a browser to a mobile device or to something exotic like Alexa or Siri, who knows, and things that haven't been invented yet. The other side of things, we wanted our development team to have a common set of tools, frameworks, languages, data, for crying out loud, patterns and infrastructure. The idea there is that we could have portable software engineers. They could move from one business domain solution to another and have the shortest new guy learning time. They'd only have to learn the domain instead of learning the framework and the language and the behavioral patterns of that development team. You can see that this is all about saving money or being more productive with the money that we have. So here is the solution. About a year ago, I stood in front of the founders of the company and said, well, what we've done is fine, but if we want to grow, we have to change. That was one of those moments in your career whether you could be fired in the next 5 minutes or somebody's going to spend a whole lot of money and do what you say. So we came up with a solution. On the right-hand side, you'll see almost a component diagram. It's not quite standard UML, but it's been refaced so that the untechnical people can look at it and recognize components. The first thing we wanted was a single web page application. Instead of having multiple page loads with all of the costs of doing that, we wanted to reload parts of the page as demanded by the user, lazy load them into a single web page application. Common components. A single sign-on, for crying out loud. Divide the work up into reusable problem solvers that we call applets. I'll explain those in a minute. Divide the navigation up, or the user navigation up into a declarative component that I call a workflow. I'll explain that in a few minutes. And then on the back end, we wanted to hide the complexity of our 400 APIs into a single endpoint using a single dialect. So we selected GraphQL and we're using the Apollo server to do that. And have a schema to describe data, so that when you go and get a campaign, it's always spelt the same way, the fields have the same semantics, and they have the same types. Just like a grown-up company, right? The other thing too, we wanted to change the way we gather requirements. We wanted to move to things like personas. So in UML speak, a persona is an actor, and what they do is a use case. So we wanted to move to that instead of some salesman in Germany selling a new feature that required a new checkbox to be put on the side of a screen and a new database column to be made. We wanted to go back to what the value was. So what did we use in terms of technology? We started out with React. There is a gazillion JavaScript frameworks. They're all really good. Our UI architect centered on React. His choice, his decision. As an architect, you have to make a choice. You have to have a reasonable reason to make that choice, and you have to sell the idea to everybody who's going to use it. We picked GraphQL both from a single endpoint perspective and a dialect between front end and back end. So a protocol between front end and back end. We introduced Node.js into the company. The reason we introduced Node.js was because the tools for GraphQL are more mature in Node.js and JavaScript. They're pretty good in other languages. They're just more mature. You can do more stuff in a smaller amount of time. For sign-on, authentication, and authorization, we use OpenID Connect and OAuth 2. Unfortunately, inside Adform, we have a little bit of a Frankenstein. It's a benevolent Frankenstein. It's not a bad Frankenstein. But what we have is we have something that we have to make, put together and stop Frankenstein's hand falling off every so often. So we've gone for these technologies. When we go out to the world of operations, we've invested in Docker containers to provide the isolation that we need for a particular service, Kubernetes to orchestrate that, and we're moving from .NET to .NET Core. so that we can take advantage of containers and Kubernetes. So what do you develop? If you were a guy or girl working for us and you were a front-end developer or a business solution developer, what would you build? On the front end, you'd build this thing called an applet and maybe some workflows. On the back end, you would build a portion of the schema that would be presented by GraphQL, a chunk of it. So that's the type definitions and the operations that you would do with it. And maybe some APIs to publish out to the rest world if we still do that. And then, like a good developer, you test everything, right? Okay, who's put something into production they haven't tested? I won't ask how it went. Sometimes it's just you just sneak it in and everything's fine. Sometimes it's you want to go and be a taxi driver instead of being a developer. My mouse has stopped working. Oh, I have a Microsoft update on my laptop. Can you believe that? Seriously. Oh, I could do it during the speech. Okay, let's talk about what the platform supplies. So we're building a platform that the business solution developer uses. I wanted to call it the Adform OS, but I was voted down, so it's now called just a platform. So there's stuff on the front side. On the front end, we have things like a single-page web application, all of the stuff to do OAuth and OpenID Connect, authentication, authorization, localization, a client to the back end, so that as a front-end developer, you are abstracted from talking to the back end. You don't have to know a lot of stuff. And of course, the whole notion of navigation, that's both the user navigation and the mechanism that causes that to occur, plus what we know as developers about navigation. Back end, we've got authorization, we've got schemas, we've got the start of CQRS, we've got a logging API, monitoring, auditing, all built in, so that you, as a developer, do your job building a business solution, not reinvent the wheel. And of course, we test everywhere because we're talented professional software engineers. So let me jump into the front end. This is the most interesting part. So we're going from a multiple page load several applications into a single web page application. If you've not done this, it is almost the same as writing a GUI application. Same principles are involved. A little bit of extra stuff. You'll notice these yellow boxes. They represent portions of the screen that we call applets, things that could be reloaded and solve a business problem. But we're going from 88 applications with, I don't know, 400 or 500 different page loads down into a single web page application. When I talk about reusable components, front-end reusable components, everybody knows what the smallest Lego brick is. It's reusable. If you have to build everything out of the smallest Lego bricks, it takes time. So React is kind of that small thing that will allow us to, React is the framework that allows us to implement that small component. The next step up is a composite component, where you take 2 or 3 things, or 5 or 7 of them, and you put them together and it becomes a composite component. Like a table view or something like that. An applet is the next level up in complexity. For the React people, it's a high order component. It has a bunch of stuff associated with it, events and behaviors that the user interacts with. It also, in our definition, interacts with one single entity, and it knows the GraphQL queries, mutations, and subscriptions to play with that entity, to load the entity, to mutate the entity, to be signaled when the entity has changed. And then you stitch all of these things together into a workflow. A workflow is essentially simply a finite state machine and an engine to implement that finite state machine. So what's an example? Let's give you of an applet. Let's focus on the simple one. In Microsoft Word, since for at least 23 years, has been built out of separate little parts. What you see when you see a picture or an Excel spreadsheet or even actually the text, these are all embedded pieces of components. The picture applet isn't part of Microsoft Word. It's just, it's actually an ActiveX component that sits out somewhere else and you invoke it, you use it. It's self-contained. What it does is display pictures. Doesn't do much else. The second component you see there is Excel. You've actually embedded that little piece of Excel into your Word document, but the behavior is all built inside of Excel. So you don't actually copy any code, you just embed them. So that's a real-world example of an applet. So here's a good example. You've all got these magical supercomputers in your pocket. You want to send an email and you want to send somebody a photograph of probably the lunch you've had today. So you make a gesture in your email application that allows you to select photographs, to choose them, to review them, and to embed them. The email application doesn't select photos for you. You invoke another application or another piece of code that's all about photos. That's the kind of philosophy from an applet. So I've talked to you about applets, what they are. They're little pieces of stuff. The one application container, one application frame is our thunk layer, has a whole bunch of services. So you get one application, one web page, and a bunch of services built in. A standard way to do internationalization and localization. A standard way to do navigations and workflows. A standard way to talk to the back end. Standard way to do all your auth things. We built that so that the front-end developer has them as a library that they can use. Essentially, the functions are injected into their code. So applets run inside the one application container. They are small problem solvers. You see on the screen there are 3 applets embedded together. They all look like one page. It's all seamless. It's all pretty and smooth and nice. But they're essentially ignorant of each other. They have some context injected into them, so they don't care where the context came from. And once they've done stuff, they don't care who gets the result. Okay, just like an ActiveX or an OLA thing. All of our new functionality is being built with applets. So I've got some code on the left-hand side there that talks about, it's essentially a React component, very, very simple, and we have, that's an applet. The applet may have some data associated with it, and it behaves something like a promise when you invoke it. When you invoke it, you're either going to get a positive, affirmative response or a negative cancel type response. So think OK or cancel, go say yes or no, forward or back, that kind of thing. So rather than the applet knowing all 400 API dialects, we're going to give it one. We're going to give it GraphQL. If you're not familiar with GraphQL, it's a way to, it's a query language which allows you to say what shape object graph you want from the back end and have it rendered for you and produced in the front end. So if you want a campaign and an order, and they're related to each other, but you only want a little bit of the campaign and all of the order, then you can get that object graph the way you want it, rather than it being a costly event. So you can see on the screen there's a green part which in the sequence diagram that indicates the low bandwidth pass across the internet. In this situation, we send a query in, it goes across as a GraphQL query, the GraphQL server parses the query, and using resolvers invokes the appropriate internal APIs, collates the result, puts it back together as a response to the query in the same shape the query was requested. So if you ask the name to be first and the age second, you get the name first in the JSON object and the age second. And if you do it the other way, it'll be the other way around. So what's a workflow? A workflow is a reusable business scenario. This is where we can stitch applets together to some meaningful use for the business. So like a use case in UML. A workflow essentially, well actually a business solution is implemented with a workflow and a few applets. Applets can be reused, workflows can be reused. When you're in an applet, you simply emit an event to say you've taken some action. That event stimulates a state transition in the workflow. So look at it this way. A workflow is a finite state machine. Finite state machines are used to minimize the amount of stack and heap space you use when you're building a user-facing application. In fact, a long time before all you were born, I wrote green screen applications, and we used finite state machines to manage the navigation of a user within the applications. I worked for a company called Wang Laboratories, and this was the company that invented email. And I was a junior programmer on the email thing. And I screwed up, I don't know how many times, but and so we had a problem with the amount of space that you could have, the amount of essentially modifiable data area or heap space, heap and stack space that a process could have in the machine it was running on. And so you simply couldn't just do a subroutine call and allocate a whole bunch of stuff on the memory because you ran out of it, because users would navigate with no plan. We put in a finite state machine. And ever since then, in every application I've ever seen or architected or been involved with, we've used finite state machines. So if you have a look at the workflow on the screen, you see the screens or the applets that get displayed, and underneath you get state diagrams that describe those, where each state is an applet and each state transition is something that has been caused by a user action. Make sense? Okay, so here's a concrete example of a declarative workflow. On the right-hand side, you have the state diagram. On the left-hand side, you have a little bit of JSON that describes it. And essentially what we talk about is some states and some transitions between those states. And the transitions have a name, and that's the name of the event that is emitted when the user takes an action. And so you could reconfigure this workflow to be in a different sequence, or to add a new item, or to have two kinds of workflows, one that would run on a browser and maybe a reduced workflow that would run on a mobile device, almost doing the same thing. But we have to live in the real world. So we have to live with legacy systems, our 88 applications. No one's going to give us millions and millions of euro to stop doing what we're currently doing, rebuild everything. Nobody can afford that. So we have to have a thunk layer. So if you're old like me, when Windows went from 16-bit to 32-bit, there was a thunk layer so that you could run 16-bit applications on the 32-bit operating system. If you're not quite so old as me, you have a thunk layer between Windows 32 and Windows 64 today. It's a way where you completely interop. And if you look at the graphic on the left-hand side, you can understand exactly what it means. So this allows us to have our old legacy applications call the one application and use applets and workflows, or go back the other way. Okay, so that's the front end. That's all the fun part. That's the pretty appealing part where we touch, the user touches. Let's talk about the back end. The first thing we needed was a common schema. There's a lot of war stories about why we need a common schema and why it's not the same. But the CEO said to me, Peter, a line item is a line item is a line item. They all should be the same. They're not. They're approximately the same, but they're not. So we wanted to have a common schema, and that's really hard to do on a massive big code base to go from Anarchy to sustainability. So we implemented a schema server in GraphQL. But because of the size of our schema, we probably have 2,000 entities in it, 2,000 domain classes in it. So to achieve that, you can't get one team to own it all. So we built some modules that allow us to team to build a portion of the schema. But this schema server, we chose Apollo Node.js service. It's implemented as a microservice. We have many instances of it running in containers, and the containers are orchestrated by Kubernetes. If you're not quite sure how to orchestrate your containers and you haven't discovered Kubernetes, here is a way for you to get your life back and be able to go home on weekends and not have your significant other angry at you because you're always on the computer. So I mentioned about schema modules. A schema module provides this little portion of the schema, and it interacts with stuff we already have. So it wraps our existing REST APIs. Or you can have a bespoke schema module, which just means a custom schema module where you write it all yourself. Or you can have a remote schema module where you can grab a remote GraphQL schema and pull it into your own, and it becomes part of your schema. And then we have a relation module that allows you to relate two things in separate schema modules together. So if you had a cat and an owner, there's a relationship there. They may be in separate modules, but you want to have the relationship between the two so you can make one query and get the cat and the owner's name, or get the owner and get all its cats, rather than making two requests. So here's an example of a GraphQL schema. So we have a bunch of types defined on the screen there. They have comments around them. The types have fields. The fields have a type. You can specify cardinality or relationship or a must-have, a mandatory field, something like that. Very simple to do. In a schema module, you have things like the types that you're going to use, the operations, which are queries and mutations, and subscriptions that you want to subscribing to an event. Wouldn't it be nice to have distributed events nicely arrive in your browser without you having to do anything? Well, this is all possible. These all get merged, squashed into one big schema at startup time. So you can see in the component diagram, we have one endpoint. It's made up of lots of little modules. The modules interact with our existing systems or our new stuff independently. At that point, in that single schema server, we can also introduce other things like an entity cache with all of the strengths and weird things that occur when you cache things, and a possibility to check data to see if that Peter is allowed to access campaign 1, 2, 3, rather than Peter is allowed to access campaigns. So a data access control list. So that's what we did on the back end so far. Let's talk about DevOps. If you have not met your DevOps people, they are legends, they are heroes. You buy them beer and chocolate, and if they have babies, you buy them flowers and diapers and stuff like that because they get everything done. So the difference is business people are similar to Captain Kirk on the Enterprise. Programmers are sort of they're really kind of like Spock. You know, he's the science officer. And DevOps are the Scotty of the Enterprise. You know, Captain Kirk says, "Warp factor 5, Scotty." And Scotty says, "Can't take it anymore, Captain." And he makes it happen. So, love your DevOps people. Make them happy. Do stuff that makes it easy for them to do. So our development pipeline, we had several, but we're trying to stabilize down to at least only a small number. So the first thing we did is we put in GitHub Enterprise. It's our repository for everything. Why did we choose GitHub Enterprise? So that's an on-premise GitHub. Adform does a lot of things on-premise. We own 2,500 servers worldwide. We don't use public clouds because of the laws associated with the way data is distributed. And at a certain point, it becomes economical to use your own machines. Okay, so that's the first thing we did. For this project, we're using Drone. Drone is a great CI when you are using Docker. It's built specifically for it. So we trigger a Drone CI development pipeline by committing, so what do we call it? Yeah, committing to the repository with in a certain branch or with certain tags. So it's automatic. Drone then goes through and tests everything. If the tests pass, then Helm takes over, which is the Kubernetes packet manager, and we can take what we have built and have it deployed through Kubernetes. We use Artifactory as our internal binary repository. What I mean by that is the stuff we've built gets put into Artifactory. So it's, our own private NPM, our own private NuGet, our own private Maven repository, anything that we need to run in production goes into Artifactory. They aren't giving me any money for this, by the way. In fact, I argue with them about money all the time. So containers. If you haven't started using containers yet, please try them out. They work on Linux really well because of C groups built into the Linux operating system. It gives you that isolation. It gives you exactly how much stuff on the machine you can use. How many CPUs, how much RAM, how much of the file system, what the file system looks like, which ports to use, even down to things like IRQs in the networking system. They are superior to virtual machines. It is the dumbest thing you can do than have this powerful Linux server and then run 10 Linux virtual machines on top of it. You don't need to do that. You might have to do that for Windows virtual machines, but that may be replaced in the future because you can say go to something like .NET Core. But please, VMs were the flavor of the month, were the most exciting thing about 6 or 7 years ago, and everybody wanted them. And I kept going, it's just stupid. By the way, VMs are not something new. VMs were invented in the 1970s where you could run isolated machines on top of a similar operating system. Orchestration. I've told you about Kubernetes. So instead of us having to orchestrate our own VMs and to load balance ourselves across microservices that we have, we use the power of Kubernetes. Kubernetes gives us the ability to have a mandatory number of instances of a microservice running and to elastically scale it and to do all of that DNS stuff to connect it all together. All by magic, well, by a declarative mechanism. So instead of us having separate little machines, we have a common cluster on which you can run, you have Kubernetes namespaces and you put stuff. Dead easy to do. Then we have Helm charts is the way that we do the package management for it. It's a declarative way to describe it. Okay, common services. All of this stuff is provided by DevOps. We don't do it anymore. We don't write our own authorization. We don't do our own logging. We don't do our own monitoring. We don't do our own metrics. It's all provided as a service by DevOps, who do it better than us, because that's what they do. Okay, so I've got a few more minutes left, and I've told you about our problem, our solution, and now, because I've got grey hair, and I've been doing this for a very long time, I'm going to give you some Uncle Pete's advice. The first thing, people are everything. Your investment in engineers is more valuable than your investment in hardware or tools. Engineers create something from nothing. We as software engineers have nothing and we make something work. There is nothing more exciting or stimulating than having the code you imagined in your mind running in front of you. You get that technical orgasm when it works. You're very proud of it. The other thing about engineers is they all have opinions and they all think that their opinion is right. And most of the time, at least a portion of their opinion is right. Okay, but opinions are like assholes. Everybody has one. And you don't necessarily want to see everybody's asshole or hear everybody's opinion. Engineers have their favorite technologies. I have favorite technologies, and they change as years go on. I had my favorite programming languages, and I had my favorite runtime environments, and all of them change. Engineers are very passionate because they're very focused, because they make something out of nothing. They love to argue. You know, arguing with an engineer is like wrestling with a pig. After a while, you realize that the pig likes it. They love to argue, and they'll argue down to the little tiniest point, but at some point, the argument becomes unproductive. So at that point, you have to say, okay, well, you've got great arguments to hear, but these other things we can't afford to do. No one's going to pay us. But engineers, regardless of what field you're in, are more creative than artists, musicians, or movie writers. You look at an engineer, you all do this, right? You sit down for 3 hours and you sit and you stare into dead space with your headphones on, and you've got all of the variables that you're trying to put together and the logic that you're going to put together, and after 3 or 4 hours, you write a few lines of code. And if someone interrupts you, like your project manager or your boss or something, when you're at, 2 hours and 59 minutes, you have to go right back to the beginning and start again. So that's the creative process. There are other days when you look at a problem and you can't find the solution. You have no clue of what to do. That's the same as writer's block. Okay, so here's a piece of advice. Avoid a dependency on a superhero. They'll get married, they'll go on vacation, they'll get hit by a bus, they'll leave the company. Who is or has been a superhero? Yeah, okay, everybody's done it, and you feel really good when you are, but you're under a lot of stress. So avoid the dependency on a superhero. If you're the superhero today, find somebody and train somebody to replace you. You're not going to lose your job. You're not going to lose your income. It's just a safety net and takes some stress off you. Okay, the other thing is we're not in the IT industry. We're in the fashion industry. And every 3 to 5 years, there is a new fashion. If you haven't been working long enough for this to hit you, it will, where you'll just become competent in this technology or this technique or this programming language or something, and then it will all change, and you're worried about changing with it. You think you'll be not valuable or anything else like that. I've done this every 3 to 5 years, new technologies, new terms, new things to learn, and it's hard. But the hard things are what makes us valuable. The journey is just as important as the destination. As a software engineer, you're never there. You're always on this journey to do new things. So don't be afraid of the fact that things change every 2 to 5 years in the industry. The other thing too is technology you knew 20, 30 years ago. Shit, am I that old? No, it's even worse than that. I started as a programmer at university in 1980, so it's 37, 38 years. Heavens forbid. Technology is additive. So what you learned in the past, although may not be absolutely relevant for the current day, is useful to form a foundation. So on the screen, I have a hierarchy or the development in memory technology since before I was born. It started out as mechanical relays. Then memory was a series of waves in a ripple tank. You had a transducer at this end and a transducer at that end, and you put bits in memory, and they were actually waves in the mercury ripple tank, and they came out the other end. Then Dr. An Wang invented magnetic cores. And then we went from magnetic cores to discrete flip-flops. So things like, and then we went to TTL and CMOS, static and dynamic RAM. If you're not sure the difference between static and dynamic RAM, I'll tell you later. And now the most modern technology we have is non-volatile DIMMs, or it's actually R memory that is RAM-like speeds with persistent storage. So Intel Optane is an example of that. And it's going to affect our futures. You imagine if all of your disk space instead of being in a file system, was all in RAM. Wouldn't that be nice? And persistent RAM. Change the way we do things. Okay, and the other thing is don't expect things to be the same. Stuff changes all the time. On that extreme left is the kind of telephone that I was not permitted to use when I was a child because my mother thought I would waste money with it. On the right-hand side is the supercomputer we all carry in our pockets. Things have completely changed. My grandchildren have no idea what it is to have a telephone that's connected to the wall. So, accept the change, adapt to it, and retrain. We all can do it. I turned 60 in 2 months. I still write code. I'm a technology architect for a large digital marketing company, and I have adapted and retrained every 8 to 9 months to learn new things. You can do it too. So don't be frightened of it. Does anybody have any questions I can answer? I can't see a soul up there waving. There's somebody right in the back there, deliberately as far away as possible.
How do you avoid people quitting because management is saying what to do?
Okay, so this is a human organizational question rather than a technology one. At some point, you being an intelligent person realizes there is nothing else you can do for the company. And that happens many times in your career, and you go, okay, well, let me look for another solution. The first part is it's really frightening to move from this comfortable place you work with the technology you have to another place. It's terrifying. I left a Silicon Valley startup software company and moved from the United States to Europe to work for Adform. And I had a little bit of money in the bank. So Uncle Pete's advice is have a few months worth of salary stashed in the bank if you can. Keep it there. Don't touch it. Don't spend it on booze or helicopters or anything like that. So have some money stashed in the bank, but at some point you have to decide that you can't stay. And then you seek another job which would be interesting, maybe terrifying, maybe hard to do. The Silicon Valley startup that I worked for, brilliant technology, but the company I could see wasn't big enough to be a company on its own. It didn't have enough stuff in it, didn't have enough strains of revenue. The other thing I'll advise you is, I know as developers we don't want to do this, but learn about money. Learn why the company gets paid and why they pay you. Learn how the business works. And that way you can see the signs early if you need to leave. If you work for, if you work for a government organization, you have to also understand why the taxpayers fund what you're doing, what value you add to the community or to the race to do that. So learn about business, learn about money a little bit, and then be intelligent about your decision, and it'll scare the living daylights out of you. Anybody else?
Thank you for this beautiful presentation. I have a technical question. Can you explain a little bit more about the security and GraphQL, how you organize it, and especially I'm interested in ACLs.
Okay, so this is a complex problem and there isn't a single solution. First up, if you can use an ID token, so an OpenID Connect ID token, that positively identifies the inbound request. So on the front end, somebody has an ID token, you pass it along with the inbound request, however you'd like to do this, but I would probably recommend in the header. The request comes in, you then take that token and check to see if it's valid from your ID provider, whoever that is. So there is a cost, there is a latency to do that. Based on that, you have to decide on a set of permissions or claims that the user has. So what we do is we look at what they want to do. So we parse the query and we determine the types that are going to be touched by that query. So if they want to see cats or dogs or elephants, we determine which types. Fairly simple to do in GraphQL. And then we check a permissions list to say, does this ID have permission to see cats? So that's the type mechanism. Access control goes down to a deeper level, which we haven't implemented yet because it's too hard to do yet. Nobody's funding us and it's just a nightmare. Where you want to go down and say, can I see the cat named Tiddles or the dog named Spot? And so an access control list for data is a great deal more work to get done. But you could, and I'm not saying you should, but you could write a small domain-specific language which described your access control list that says, Peter is allowed to see cats named Tiddles and dogs named Spot, but not elephants named, I don't know, what's an elephant's name? I don't know. So that's one technique you can use. That's what's rolling around in my mind for our access control list sometime in the next year before I retire or get hit by a bus or have a baby. Somebody else? Nobody else? Okay, thank you very much for listening to me.